Hi, I'm Alan Ross. I'm the managing editor of APC Media, or APC Technology Productions, Transformer Technology, Power Systems Technology. We are here at the RE Plus 2023 event in Las Vegas. This thing is huge. It seems like the battery storage people have come here. So we've got wind, solar, battery storage, and everything in between. But hope you enjoy these interviews. I love interviewing the technology of the future, and enjoy. My guest is someone that I've had interviews with before, and he's a delightful interviewee. Denis Phares is the founder and CEO of Dragonfly Energy, and you've got your pulse on the marketplace. So we're going to first of all talk about what changes since the last time you and I interviewed, and it's been a little over, what, 2 years or a year?
Oh, less than that, I think. We were at, in San Diego. Well, first of all, it's great to be back. Alan, thanks for having me back. It is a rapidly evolving industry, obviously. There's so much that is happening because we're in the middle of this transition, a major global transition. So if I were to say, identify what has been changing lately over the last half year, over the last year, a lot of it has to do with just exposure in terms of the understanding of what needs to change over the next couple of decades. And if you look at RE Plus here today, what I've noticed, it's all batteries. There's a lot of batteries here.
Yeah, batteries. I think the whole floor upstairs is full of battery presenters. You said something about, it's evolving, but we're still identifying the problems and still trying to figure out how to merge 1,000 solutions into the problems. And there'll be winners and losers. The people that figure it out will be the winners, but a lot of it comes about to collaboration of the overall problem. Define the problem a little bit more clearly today than maybe it was a year ago.
Wow. Well, the overarching problem is, how do we get our energy? Right? How do we produce electricity and deliver electricity in the most efficient manner? And one thing that we are recognizing, especially over the last year or two, is there are tangible effects on climate that we have seen from burning fossil fuels. And so there's a desire to do less of that, without sacrificing our way of life and our lifestyle. So it is a very interesting mix now of technology and money and financing and politics and just general public perception.
So where does storage fit in the midst of all of that? Because from a generation standpoint, we're moving to much more wind and solar. That's part of this. So they're trying to say, okay, let's move to that. We'll get some geothermal in there. People still trying to build a nuclear plant. It's not going to happen in the United States, but in my opinion. But let's assume that the generation is working. Now, on the other end, you have electrification of everything, especially transportation, right? And that creates a whole storage problem of where things go. Now, I know Dragonfly has a very unique solution we're going to talk about because you've applied it, you're out there in the marketplace. But talk about the gap between the generation transmission, let's assume that the politics will figure it out, but really the distribution and the electrification of society, because that's what we're really about, right? Electrification of society. Talk a little bit about where storage plays a part in that.
Well, you've got the downstream aspect, which is the electrification of things like transportation, and you've got the upstream aspect, which is the solar and wind that you talked about. And from a downstream perspective, we need to have the energy delivered when it's needed. And from an upstream perspective, the energy is delivered only when the sun is shining and the wind is blowing. So that's what needs to be matched up, and you need storage to basically create that buffer, and it has to be large enough to be able to take in the energy when it's being produced and deliver it when it's needed.
That's because one of our interviewees is Infinity, and they have an ESS large storage solution that they bring to market. When you see more flow battery people, and I remember 5 years we were talking about flow batteries as not viable. Now they're talking about they are. But that's large energy storage. Talk about some of the technologies, not necessarily what Dragonfly does, but some of the technologies that seem to be more promising that may be large to, in the cars or whatever. Talk a little bit about what's happening in that space.
Well, there's so many ways to store energy. You can store energy as electrochemical energy, like in a battery. You can store it as gravimetric energy, like pumped hydro. You can store it in kinetic energy, like flywheels. And there's just so many ways to do it. And ultimately, what technology needs to do is, whatever you're doing, it has to be cheap. So it's all about bringing the cost down, whether you're making new batteries, whether it's flow batteries or lithium batteries or flywheels or whatever you're doing, it's got to be inexpensive enough that it makes sense for application either by end users if you're off-grid or by utility companies if you're on-grid.
Okay, excellent. Now I want to go specifically to Dragonfly. It's been a year. Talk a little bit about your particular technology in this space, because you invented it, correct? And then let's talk about what you're experiencing as one of the solution providers to the marketplace.
So we have been working on cost reduction, and the way that we've done it is by changing the way lithium-ion cells in particular are manufactured. So we've reduced the cost of manufacturing. Now we haven't done that in our current core business, our current marketplace, where we are assembling battery packs for things like RVs and boats and industrial solar applications. In that regard, we're competing with lead-acid batteries. So from a cost perspective, we're already there in that arena. But when we want to revolutionize the grid, the cost has to be much, much lower. And so that's where we need to deploy our cell manufacturing technology, the dry electrode process we've developed. And we just completed our pilot line. So that's where we are now. That's what happened since the last time we talked. We've completed our pilot line. We've begun to produce anode. The next step is to produce cathode, and then by the end of the year, we expect to produce full cells.
And when you say the pilot project that happened, talk a little bit about that. How did you decide to do it? Did you get financing and funding for it? Because it's not cheap to do everything that you're doing.
Right, so it's actually a pilot line. So we built a pilot line to produce on the order of, we think about 150 megawatt hours a year. So it's not a very large scale gigafactory, but it applies our innovative dry electrode process. And how did we finance it? Well, that's why we went public last year. So we had to raise the capital to do that.
Right. I hope we helped get the message out about you going public last year. That's good. I want to talk about that scale up. You got to go now from the anode to the cathode to the scale up. The plan for doing that, and you talk about 150 megawatt hours. Is that what you're trying to get? Scale, what does that mean? Does that run a city? Does that run my house? Talk about what you're trying to scale it to.
I mean, 150 megawatt hours annually for a lithium cell manufacturing plant is small. Right. So, I mean, you're talking, niche applications there, maybe a consumer electronics application by scale. Not that we're making those types of batteries, but if you want to make enough batteries to make a dent on the grid, then you need many gigawatt hours. We need to be in the terawatt hour range to really make a dent there. So everything's going to help. We're doing our bit. We're doing what we can to apply one technology and lower the cost. But I think everything is going to contribute.
Is that a proprietary technology?
It is.
It is.
Yes.
So do you think you will scale? You'll just be able to scale, or are there certain size factors that, size matters, right? You get to a certain point where you say the technology won't work at this level or not?
No, I know we will scale. The point of the pilot line was to demonstrate that we can scale.
Dennis, you got to save the world. That's what we need. We need technology that fits, that works, because your technology has been applied before. It's not like it's a new technology, and it works in boats, RVs, and does it work in automotive?
Well, I want to be clear. The technology that we've deployed in terms of our battery pack assembly is not the same as the cell manufacturing that we've done, that we've completed the pilot line for. So we will make the cells and then put them in the packs that we're already assembling and putting it out in the marketplace. Can the process be applied to EVs and car batteries? The answer is yes, it can. It's a chemistry agnostic process. We can make lithium iron phosphate cells, LCO cells, NMC cells, so it is very versatile.
Excellent. You're part of the future.
We're working on it.
I appreciate that. Last question for you. You're here at RE Plus. This is what, your third, fourth? How many times have you been to RE Plus?
I think third or fourth, yes.
Fourth, okay. You've got a booth here somewhere, right? I'm not going to find it because I'm going to be stuck here. What are you trying to say to the market from being here at RE Plus? What's your message?
Well, you know, this show used to be the SPI show, the Solar Power International show. Now it's the Renewable Energy show. So it sort of highlights the fact that it's more than solar. Now you've got the issues associated with the storage and the transmission and all that stuff. So the reason that we're here and what we hope to get out of it is we want to form collaborations, we want to form partnerships, potentially find investors, potentially find customers. This is the place to be. I mean, my goodness, there's like, you have to be here. Everybody's here.
Yeah. So I hope this will convince investors to say, you know, you got to put your money where it's going to make the biggest impact for the longest period of time that can scale. And I absolutely believe in what you're doing at Dragonfly. Thank you for meeting me again. Thank you for being here.
It was my pleasure. Thank you, Alan.
Take care. Bye, Dennis.